Imagine if your brain forgot what happened just a few seconds ago, like trying to watch a movie where every scene disappears instantly. That's what happens to regular neural networks when they try to understand sequences. But LSTMs change the game. Today, we'll break down LSTM networks in the simplest way possible. Before we dive into LSTMs, let's quickly recap what recurrent neural networks, or RNNs, are. They're designed to handle sequences of data, like sentences, stock prices, or audio. Unlike feed-forward networks, RNNs pass information forward in time, like a memory chain. But they come with problems too, which we'll explore. Here's the problem. RNNs suffer from what we call the vanishing gradient problem. Imagine trying to remember what you ate for breakfast last week. The details fade away. Similarly, RNNs struggle to remember information from far back in a sequence, making them weak for long-term memory tasks. Enter LSTMs, or long short-term memory networks, invented in 1997. Think of them as a smarter memory system for neural networks, like a notebook you carry, to jot down important details while ignoring the unimportant stuff. LSTMs solved the vanishing gradient issue and gave neural networks a much longer memory span. So, what makes LSTMs special? Inside each LSTM cell, there are gates: the input gate, forget gate, and output gate. Imagine a water pipeline with smart valves. Each gate decides what to keep, what to throw away, and what to pass forward. This selective memory is what makes LSTMs powerful. Let's make it super simple. Imagine preparing for an exam. You don't memorize every single word from the textbook. You highlight the key points. That's what the LSTM does. The forget gate erases useless info. The input gate highlights new info, and the output gate shares the final answer. Let's see LSTMs in action. One famous example is text prediction, like when your phone guesses the next word you're typing. LSTMs look at the past words and predict the next one by remembering useful patterns, such as grammar and context. Without LSTMs, text prediction would be frustratingly bad. Another major use of LSTMs is speech recognition. Think of Siri or Google Assistant. They process audio waveforms over time, needing memory to understand full sentences. LSTMs allow AI to understand the context, not just individual sounds. LSTMs also shine in predicting stock prices, weather, and other time series data. For example, by remembering past temperature trends, an LSTM can help forecast tomorrow's weather more accurately. This makes them crucial in finance and climate research. Now you might be thinking, are transformers more popular today? Yes, but LSTMs still matter. They're lighter, easier to train on smaller datasets, and still widely used in industries where efficiency matters more than scale. They're like the bicycles of AI, not always flashy, but reliable and effective. Quick reflection time. Question: why do LSTMs have gates? Answer: to control what information is remembered or forgotten. Another: where are LSTMs still useful? Answer: text prediction, speech recognition, time series forecasting. Doing these little checks helps solidify what we've learned. So to rack up, RNNs struggled with memory. LSTMs fixed it with gates, and they became essential for sequence tasks like text, speech, and time series prediction. Even though transformers dominate today, LSTMs remain an important milestone in AI's history, and a tool still in use. Thanks for watching, and don't forget to like, share, and subscribe for more beginner-friendly AI breakdowns.